Hey, this is Joe at graybenchelec. Welcome back to the bench. So a couple weeks ago, we looked at the Earthquaker Zap Machine. This is a rare pedal from Earthquaker, now discontinued. They made two versions. This is the version 2. 350 of these were made for Primax, the music store. There was a version 1, of which 20 or so were made. You pretty much never see those. So during the teardown, we looked at the physical pedal itself. The components are all through hole here, carbon comp resistors, germanium transistor there for the Q3 or third transistor stage is sort of a transistor boost into a fuzz face. We'll look at the schematic a bit in a second. This is the version 2, so it has the sort of two-sided, two gain controls, and it does a little bit of control over the gain of the second, or I should say the first transistor stage of the fuzz face to get a gainier side as opposed to the, so that's the red side, and then the green side is a little calmer or less gainy. So that is the version 2 Zap Machine Earthquaker. If you want to see more about that, go check out the teardown I did a couple weeks ago. So the Earthquaker Zap Machine, it sells for quite a bit on Reverb. If you go look at sold listings, anywhere between like 500 and 650 bucks. I paid a little more for this one because I wanted to get it and show it off for the channel. I didn't want to miss the opportunity. And I'm fortunate enough to be able to set aside that kind of money to pick up more expensive pedals like this. However, I usually will not hold on to something like this just because it is quite expensive. That being said, I do like the sound of this pedal. I think it's a good sounding pedal. And being rare, it's something fun for the collection. And also as a pedal builder, I have an alternate route to keep pedals like this, and that is to build my own. And so that's exactly what I did. I went and designed a PCB around the schematic for the Zap Machine. It's not a direct clone, and we'll look at the two schematics side by side in a second, but it is definitely inspired by the Zap Machine. So now I've got my own, and I can release this back into the wild. So first up, we'll have a look at the schematics for the Zap Machine and my clone, and you'll see the changes that I made for the clone. After that, I'll show you the inside of the clone, and you'll be able to see how it's built and the PCB that I designed for it. So first up, we're going to look at the schematics for the two pedals, the Zap Machine versus my clone, and I'll show you the changes that I made. After that, we'll have a look inside of my clone, and you'll be able to see how I built it, the PCB, all that. And then we're going to do a head-to-head listening test to see how well I did in terms of recreating the sound of the Zap Machine. And be sure to stick around to the end if you want to build your own clone. I do have some PCBs left from this build. If you're interested, they will be available, so stick around for that. All right, so here are the two schematics for the pedals, the Earthquaker Zap Machine here on the left, and my clone or modified clone here on the right. We're going to do a quick flyby of the Zap Machine again, just to refresh everyone's memory. Coming in here, we first hit the base control. This is just sending a variable amount of signal between either the 10 nanofarad input cap or the 4.7 microfarad input cap. The larger cap is going to allow through more bass. Then we have our first transistor stage, voltage divider biased, 100 nanofarad cap out to the two gain controls. So this is the first part of the channel switch on the V2 Zap Machine. You're switching between two gain controls of the same value. You can just sort of have preset gain controls with either A or B. Coming out of that, we have the fuzz face. So this is a sort of hybrid silicon germanium fuzz face. 2N3904 is a silicon NPN. 2N1302 is the NPN germanium. Second part of the channel switch is here as well. It's putting either a 1K emitter resistor onto the 3904, the first stage, or just as the fuzz face would be connecting the emitter straight to ground, which is going to give you more clipping and asymmetric clipping from that first stage of the fuzz face. The third pole of the channel switch is just switching the LED, so it's a bicolor LED, switching between red and green. That's the third part of the triple pole double throw channel switch. We also have an adjustable bias for the germanium with a 20K trim pot. Coming out of the fuzz face, we go to the treble control, which is, I didn't realize it at the time that I did the teardown, but it's actually the stupidly wonderful tone control, originally designed by Mark Hammer, and then this version is the modified or improved version by Jack Orman. I'll put a link for that in the description. After that, we have a little bit of tone shaping and then the volume control out. So that is the Earthquaker Zap Machine. Here's a schematic for my modified clone of the Earthquaker Zap Machine. So first up, we come straight into the same base control, same transistor boost stage. Coming out of that, here's the first change I made. I just ditched the channel switching idea. I didn't really understand the utility of it. It's not something I would use, I don't feel, so I just kind of scrapped all that and just went with a standard gain pot, same value as that machine, 500K audio, but just no extra channel switching. That idea is gone. Single gain pot, coming out of that, going right here into the fuzz face, same as that machine. Still the silicon and germanium transistors, same feedback network here, the 220K and the 1 nanofarad. Another change here that I did, instead of having the channel switch, which is already gone, having that switch between either a 1K emitter resistor or just grounding the emitter, I went for a reverse log 1K potentiometer because I found as I was messing around with it on a breadboard, I liked some of the in-between sounds, in-between gain settings that you could get between 1K and fully grounded. And so this potentiometer lets you tweak that to your preference. I call this control the bite control, because as you get closer and closer to grounded emitter, it gets more trebly and bitey and gainy. But there's some in between stuff that's pretty cool too. The one caveat with the bite control is that it's just a potentiometer, and it does have DC voltage on it from the transistor. And so when you turn it, it's going to sound scratchy. It's normal. There's nothing wrong. It's not going to hurt anything. When you let go, the scratching stops. But just know, if you happen to build a pedal like this, you're going to hear scratching as you turn that knob. It's normal. The rest of the pedal here is all the same as the Zap Machine. Same stupidly wonderful tone control from Mark Hammer, Jack Orman. Same mids adjusting tone circuit here, same volume control out. So the main tonal changes were ditching the channel switching and just going with a single gain pot, and then adding in the bite control, a variable emitter resistance for Q1 of the fuzz phase, or Q2 for the pedal. Also up here, we ditched the channel switching LED, the bicolor LED, all that's gone. And the power supply is switched up a little bit. Instead of doing reverse polarity protection here with a diode to ground like this, I prefer to use a really low voltage Schottky resistor like a 5817, one in 5817, just in series with the voltage. That way, if you connect reverse polarity or incorrect polarity voltage to the pedal, it'll just shut it all down. It just blocks it. Same filtering, 100 microfarad filter cap, 100 nanofarad cap also helps tame some noise. 100 ohm resistor, filter resistor in there. And then just a standard LED bypass on or off with a 4.7K resistor. You can modify this resistor value depending on what LEDs you have. Take different resistors, 9-volt battery and LED, and see what brightness works for you. So yeah, there's the two schematics for the two pedals. Let's go ahead and look at the clone that is built. All right, so just as a quick refresher, this is the Earthquaker Zap Machine, of course, the original pedal. We have some mojo parts. We have carbon comp resistors, we have through-hole high voltage capacitors, Mallory capacitors. The germanium transistor is a Texas Instruments 1302. And then, of course, the two silicon transistors, the 5089 and the 3904. Alpha pots, Neutrik or Rian plastic housed quarter-inch jacks, the black alpha 3-pole double throws. That is the Zap Machine inside. Moving over to the clone. And so because I didn't go for any of those axial components that the original pedal has, I can make the PCB a lot smaller. The circuit matches the schematic we just looked at. In this case, I didn't go for carbon comp resistors because I don't care. These are metal film resistors, quarter watt, of course. In this case, the germanium transistor is a 1304, which is a higher gain bucket or sorting for the 1300 series. There's a whole series from 1300 all the way up to like 1309 that are all germanium, and they alternate NPN or PNP depending on the last number. So the odd numbers are PNP, and the even numbers like 1304 or 1302, those are NPN. In this case, the germanium transistor is a General Instruments. You can see the GI logo on the top there, 1304. So theoretically, a higher gain bucket, but germanium transistor gains vary wildly. In this case, what I ended up going with is a pretty low gain transistor because I found that sounded the best to me. So I believe, we'll look at the transistors in a second, but I believe it is around 40 some HFE on that transistor. As far as the other components, I believe these are Switchcraft enclosed jacks. I've got just the standard non-switching 9-volt DC jack. There is enough room. You could put in here one of the switching Kobicon jacks. I just didn't put one in because I didn't put in a battery snap or anything like that. Pretty standard. It's got some WEMA and Chemet film caps, Nichicon electrolytics. Same part numbers for the silicon transistors, 5089 and 3904. The foot switch is one of the Gorva foot switches. Super light actuation pressure, and according to them, it also lasts longer. And same alpha potentiometers. There's 5 pots, of course, 5 controls, volume gain, treble bass, and the bite control that I added to the circuit. And those are all alpha pots, and of course some are hidden under the board. And the enclosure is the 1590N1 enclosure from Hammond. All right, let's do an HFE test on the transistors. I've got the 5089 in the test probes here. This is a Central Semiconductor 2N5089. Let's give that a test. All right, so that is, of course, an NPN silicon BJT, HFE 561, and of course, no leakage. It's sort of just habit for me to go down to the leakage because I usually test germaniums, but for silicon, if you have a leaky silicon transistor, you should just swap it out for a different one. All right, here is the 3904. This is, I'm not sure what manufacturer that is actually, 2N3904. It might be Philips, maybe. All right, NPN silicon BJT, HFE 179, and of course, no leakage. So that is 3904 gain. And now really the only one that matters, the germanium. This is a 2N1304 from General Instruments. and that is testing as an NPN germanium BJT HFE 64, so a little bit higher. I thought it was 40 some. It might be a discrepancy between the two germanium test methods. I use the DCA 75 here, which tests at 5 milliamps collector, but the RG Keen tester tests at a much lower collector voltage. So I might have, when I sorted them into gain, I might have tested this transistor with the RG Keen method. Yeah, so NPN germanium BJT HFE 64. Leakage is no leakage. That's not surprising. The 1304 or 1300 series I found to be really low leakage, regardless NPN or PNP. Just give it one more try just to be sure. 64 HFE, a little bit of leakage, 15 microamps of leakage. So yeah, personally I recommend for this pedal sticking pretty low in your gain, something definitely under like 70 HFE. Anywhere like 40 to 70 would probably sound pretty good. This would actually be a really good opportunity for the Soviet transistors because those tend to be pretty low gain and low leakage. All right, so just like the original pedal has the trim pot and a bias test point, it is also important to bias the germanium transistor for the clone here. Now, it would have been nice for me to add a little test point just like Earthquaker did, but I just forgot to do it. And so it might be a little hard to get to the collector, which is where you want to test or probe to check for the collector voltage. The little trim pot I have here actually has an exposed pad, so I can get to that collector voltage. We can see there it's a little bit low. I'm also using a 25K pot here because it didn't have any 20Ks. 20K, 25K, either one will work fine. With the 25K, it's just going to be a little bit harder to make fine adjustments. All right, so now we got the collector of the germanium sitting about 4.5 volts, which is approximately half the supply to the pedal, 9 volts. So that is the quote-unquote optimal bias for that transistor. Now, of course, you could mess with that a little bit, you know, tweak it up to 6, down to 3 or whatever to see how you like it. It's going to change the tonality and the quality of the signal coming out. So feel free to mess with that a little bit. But 4.5 volts is the optimal setting, quote unquote. All right, so since we're here, let's have a look at the voltages for the other transistors. So this should be the collector of Q1. It's right about 4 volts. The base at about 0.78 volts. And the emitter at about 0.19 volts or 0.2 volts. Over here on Q2, the 3904, this is the emitter. So this voltage is going to change as we adjust that byte control. So all the way turned up on the byte control, which is maximum fuzz, you could say. The emitter is grounded, so we're getting 0 volts or connection to ground. And as we turn that up, that voltage is going to increase all the way up to maximum or minimum on the byte control is 0.34 volts. Base, we have 0.96 volts, and on the collector is 1.5 volts. And of course, the collector will follow the byte control as well. All right, so next up, let's have a listen to these two pedals side by side, and we'll see how close I got. All right, we're set to do a listening test. We've got the Earthquaker Zap Machine in one corner and the modified clone I built in the other. This little looper thing I built here is just an A or B switcher. It's true bypass. So when I hit the switch, it's only one pedal in circuit. The other pedal is completely out of circuit. For audio, I've got just a little looper pedal here that I pre-recorded a guitar loop. That way it'll be the same audio going into each of the pedals. For recording, I have a 1x12 sort of modded basement amplifier, a SM57, and the guitar was a Telecaster with a humbucker in the bridge. So let's have a listen to the clean signal. All right, so that's the clean signal. I'm going to turn them both on. Don't know which one is which. We're just going to have a listen first and see if we can figure it out. And hopefully they sound pretty similar. All the controls obviously are set as close as possible. Let's double check. The byte control is at 0 because that would be equivalent to the green side. Gain's even. Yeah, it looks pretty even. Okay, let's go. right, so they sound pretty similar here in the room. We'll have to listen to the recording to really tell. So let's try going to the red side of the Earthquaker, which would be equivalent to the bite all the way up on the clone. I'm gonna set the gains back to noon, or gains noon on the red. Volumes around 9 o'clock seem to be about right. Trebles are about 10 o'clock or so. Bass is straight up and down. Let's turn the loop back on and see how the red side, red side sounds. All right, so from what I can tell, these two sound basically identical. Maybe I could detect a slight difference in tonal quality. It seems like the clone might be a little bit gainier just for a given position on the knob, but they absolutely, you know, if I was in a live setting or any type of not like super close, hard listening like we're doing right now, there's no way I could tell these apart. So that's good. And it just reinforces the truth, which is that if you take the same components with the same values, hook them up in the same way, it's gonna sound the same. All right, and like promised at the beginning of the video, I do have 9 of these PCBs left over from this project. So if you like the way that sound and you wanna build one of your own, I do have PCBs here. There's only 9 of them. And so I'm gonna sell them for 10 bucks and it's first come, first serve. Please, only 1 PCB per person. I wanna make sure as many people get them as possible. If you are watching this video from the future, chances are these PCBs are already gone. But if you are still interested in making a clone of the Zap Machine, I would recommend just keeping an eye on the major DIY PCB manufacturers. I can't say too much because I don't know how set in stone it is, but just keep a lookout and I have a good feeling that you are going to find a PCB that will work for you. Okay, I think we're gonna wrap up the video here. I hope you enjoyed listening to and watching me build my modified clone of the rare Earthquaker Zap Machine version 2. If you have any questions, feel free to leave them in the comments. If you are interested in one of those PCBs, check for the Reverb store link in the description. Supplies are very limited. If you are interested in the original Zap Machine version 2, this is number 141. It will also be available in my Reverb store. Check for that. I'm Joe from Graybench Electronics. Thanks for watching.